20 minutes for this presentation. So I request you all to please
Good afternoon, everyone. Thank you to ACC Hyderabad Chapter Nakshiranji for giving us such a great opportunity to showcase our company and what we do. So, my name is Panikar Reddy. I am from Nagarjuna Steel Group. I am here this afternoon at this wonderful conference to give you all a background of who we are, what we do, and how all of us can build a brighter future together. Nagarjuna Steel Group was founded in 1992 by our CMD, Shri Mahendra Reddy. He is a civil engineer by profession. His passion for building safe and equitable homes at affordable rates for all people of our Telugu state made him start his journey in the steel and cement business. His strong business acumen, discipline, and hard work ensured the success of his venture. Our group mission is to supply superior building quality products with great after-sales service. This we also do with utmost transparency, so no customer or no builder of ours ever gets cheated by buying their steel. We empower our employees as entrepreneurs or partners in our retail outlets. We have grown many people to be honest, dynamic and decisive with home builders and architects. With our CMD's guidance, we have completed over 10,000 building projects, helping lakhs of people realize their dreams of building their own homes. We have also achieved a group turnover of over 1,000 crores. We have prioritized building relationships with the architecture fraternity very early. Architects are very critical when it comes to designing, executing any building activity. Their analysis and opinions help us create safe, secure, and long-lasting structures, and we thank you wholeheartedly. So there are a lot of products in our portfolio. We were appointed as distribution partners by GSW for Telangana in 2017. In the same year, we also had the privilege to get RIN, Rashtriya Ispat Nigam Limited, to be a distribution partner. We are also associated with Tata Structura. Now, our in-house product which we make is Nagarjuna TMT. This is Nagarjuna TMT 550 and which has a lot of numerous benefits for it. These include consistent quality across the bar, best bonding capability with cement, high level of purity, higher fitting strength, transparent pricing, excellent ductility, better corrosion resistance, excellent thermal capability, higher availability, and we have mastered the distribution network early in our period, so that's why we will be able to supply this product anywhere at any time. We meet all the ISO standards and we are also going for BIS in the near future. Now I want to take this opportunity to introduce the product produced by our epoxy and fabrication division. Vijay Kumar sir. tons. There is a cut and bend and tying. We have to build the contractor at 5,000 rupees per ton. There is a market worst rate I am taking. Then wastage 2.5%, which I have taken very less. Then accommodation of the labor, establishment of the labor, then machinery supply to the particular contractor. And after that, I have considered the 2.5 wastage can be reset back to the customer. Then you will get some amount. After when it's all those things, the expenditure against 1 ton is 6,615 rupees. This is a net expenditure to the customer or contractor whoever. If he buys the steel and keep at the side and cut and bend whatever. There are another comparison statement I have given which if you use the ready-made steel. The same thing, all costs I have given, including paying everything. This is also costing 6,331 rupees per ton. The advantages of the using the ready-made steel. Quick delivery that is ready for the installation. First of all, after getting the ready-made steel in the side, directly you can type according to the shop plans. That is the ready-made steel, like the ready-made concrete, how we have. The second, minimum mass wastage, because we optimize the steel and we will minimize the steel. Because optimization is in the sense of the software control. We will use the cut lines or after another GPS. So like that we will try to minimize the wastage of the steel. Then a significant reduction in construction time. The construction of the strength and the structure of the building will be completed before the project. It is 100% sure because I am sure that I have been working since 25 years in this field. We will gain lot of time by using ready-made steel. Other thing, the quality in production according to the BIS standard IS 1796 2008 and IS 2502 1960. This is very important point. So why if they want to cut a bar, okay, to get the bar, because they will cut the bar and bend it. Whatever bending mandrels, whatever bending mandrels they have, it will be like a 20 mm margin. They will use for all the elements of the bar, which will increase the quality of the bar because there is a standard saying on the 82502. There are several standard mandrel sizes which we have to use according to the diameter of the bar, 60, 20, 25, 30. But we maintain in my factory according to the IS code. We build accordingly. The benefit of the one is the cut line. If you use the specified mandrel according to the standards, the cut line will become less. So automatically the weight become less. The advantage is, so we are sure that we will view of the quantity, the designers, the structural designers who declare the quantity of the steel. So definitely it will match to the VOQ of the quantity if you work according to the ready-made steel. But I am sure that it won't match if you go for the site classification. This I can say. And it will optimally minimize space on site and lab requirements. The lot of space we have to provide if you go for the fabricated site. But where the ready-made, we will shut only the required steel which they require to concrete. That is the main approach. So then, these are the cabinet views, and we have another project of making a epoxy coating, and Mr. Srinkar will come and introduce about that. Thank you very much. A very good evening to all. Myself, Srinkar Verma, and our next feature is fusion molded epoxy coated EMD bars. We have a facility at NATCON. We have a facility at NATCON for fusion molded epoxy coated reinforcement bars. Corrosion can be viewed as a universal phenomenon, omnipresent and omnipotent, which is everywhere, like air, water, soil, and environment we encounter. There is no single figure for loss to the nation due to corrosion. It can be a minimum of 3.5% of the nation's GDP. Losses due to corrosion could be around 2 lakh
manifest in the form of premature deterioration or failure, unnecessary maintenance, repairs, and replacement of damaged parts. Our prime motto is to build a stronger and corrosion-free nation by using user-coated epoxy-coated TMT bars so that to make corrosion-free India. And these are some pics of our factory facility. We have our short casting machines, which we prepare the surface preparation so far, and we do maintain this SA2 of standard with the help of Swedish standard. And after this, the blasted surface should visibly look to a near 1 centimeter and meet the requirement of SA2 or Swedish standard. After that, it will get into this. Then surface preparation. After then the temperature checks we have to maintain with the help of oil. After that, the surface profile. Temperature shall be controlled as recommended by the manufacturer and ensure that workman job without disturbs, voltage or any other surface defects. After then, the TMT bars, whatever is in surface prepared, it will get into this preheating temperature and then coating wood, where this epoxy has been completely insulated. The thickness of coating shall be maintained between 100 microns to 300 microns of the coating. And after that, we have our own finishing zone, and when all of this process completed, then we have our quality laboratory, in which we have this strict testing equipment so forth, and in this we have this chemical resistance test, abrasion resistance test, coating thickness test, quality test, impact test, and so many tests are strictly conducted. And some of our prestigious projects we have done so far. It's in Divi's Laboratories, East Godavari, Tata Projects ONGC Kakinada, Deccan Infra Projects, it's in Amlapuram, Rokera Engineering at Baleshwar, Orissa, and Shantikunj Independent Vikas in Kottur, Telangana. And this is how the bars will manually loaded into the trailers. And this is Rokera Infra Project, ongoing project at Orissa and AP. And another project is Big Infrastructure. And next, coming to the point, is Mr. Neeraj Pandey will take over the dais. Thank you.
Thank you, Shikhar. Hi, everyone. After lunch, everyone's living like. No, I'll take only 2-3 minutes about our new feather. Myself, Neeraj Pandey, Vice President, Muttan Steel. I'm heading this Muttan Steel business for Andhra and Telangana. In Navigational Group, third feather in Muttan Steel. We are the business development partner for Tata Structure, Tata Wire, and Tata Agrico. We have product range of Tata Structure, a very wide range of products like square, rectangle, circle, hollow section of YST 210, 310 and 355. Mainly 210 YST. 210 YST right now this is using in scaffolding, in real estate like railing, grills, grates, everywhere, and this is the retail business. In project mainly we use 310 YST and 355 YST. We are having this Tata Wire also in this lot of wide range of wire product like barbed wire, chain link, knotted fence and 3D wires. And we are the also business development partner for Tata Agrico. In last 2 years we did lot of projects. When it's time for nation building, Tata Steel is one of them. And as a partner of Tata Steel, we supported and supplied lot of projects in India. Like we supplied material for the Shimoga Airport, Palam Airport, ongoing right now, Goa, and proposed Navi Mumbai. We just got the order for Navi Mumbai International Airport. And already we completed this Visakhapatnam. Hyderabad is still completed, some work is pending, and it will complete in next 6 months. Most prestigious project, Central Vista. We supplied around 600 to 700 tons material to the Central Vista at fabrication is at Daman. We supplied to material to the Eurocaustic, and they fabricated at Daman and installed at the Dali in new Central Vista. We already given 3 stations for this bullet train projects, Ahmedabad to Mumbai, already supplied to around 1200 tons. And last one is NTPC, Ramagunda. Siddhar Reddy sir is there. He is the consultant for this Telangana Secretariat, and we supplied material for this also. Again, Siddhar Reddy sir from Sri Harsa Consultant. He is the consultant for this Lumini Park, Deepam, and still supply is going on for this. And this is the cold storage. We constructed it a Guntur G+5 with 700 tons. Its capacity is 1.5 lakh million tons of this cold storage. And this is our own facility at NS Epoxy at Rakam Charla. As I told you, we are having this Tata Wire and Vision Development Partnership for the both states, Andhra and Telangana. We have lot of products in this also, like knotted fence and 3D weld mesh. Now I'd like to call my CMD, Mr. P. Mahendra Reddy, to conclude this presentation.
Thank you very much for giving the opportunity, this occasion sponsoring for the ACC all team. Thank you very much, sir. As a small trader, last 30 years I became a very portfolio of these are all portfolio. I have prestigious companies given the distributions and own in-house productions also we are doing. So the motive is, my son told me like that. So consumer is always to God. This is the only the motive. Always consumer has to be happy. Whatever the innovations, whatever the new products, whatever your designs, whatever you people are giving the new enthusiasm designs or whatever new targets, we want to give the, as a supplier, as a productor, as a distributor, I want to give the best quality of the product, best services, and very, very profitability to the consumer. This is the motive of our vision. And with your blessings, I started my career with your consulting engineers. Many of the consultant engineers support only. So that's why I am very much love to you, your organization, you fulfill of the things. So as well as these things, I am prepared lot of entrepreneurs. I give lot of opportunities to new entrepreneurs to become they are from unemployment to the employed to the entrepreneur, like a way I am started. This is going on in Hyderabad, around 50 outlets we are having. This is a giant partnerships of my colleagues or whatever my partners. And as well as in AP and Telangana, I have a last of network, it's a dealer network, 300 dealers, and as well as with your support, many of the projects we are supplying in AP and Telangana. And as well as we are outside also some of the big fabrication PEB constructs, PEB fabricators, contractors are companies. So we are giving out of the India, we are supplied one of the prestigious project in Maldives also. So these are the opportunities coming. When the motive is a positive and goodwill, so I can get anywhere, any success story. I believe that. So this is my simple this thing, sir. And as well as as a part of this thing, social also, I am a part of the social organizations of the old age home and orphanage home, and many of the school buildings, schools, toilet blocks, all wherever the need is there, any people will come to me, know to me, so I am ready to support them, so give the good cause of the nation and good cause of our humanity. And at the COVID time, lot of we are given services to the poor people, food grains also, as well as concentrators, oxygen cylinders. We are supplied to the hospitals as well as free to some COVID patients and the things. And in Kasargod, there's a the prestigious project at that time going. All lockdown also, we are supplied lot of material in our go down to the Kasargod also. These are the people with the police department. I took the permissions and supplied to the site the material at that time. These are the challenges. Wherever the challenges will comes to in my mind to the humanity ground are positive things. I am ready to always and my motive is I want one of the leading organization in the steel by innovation and improve these services. This is my motive. Thank you very much. Given the opportunity, Rajkumar sir and President Ravi sir, I am very much thank you for this. Just thank you.
Please stay back. He needs to stay here. Yeah. Thank you so much. That was really nice to hear about the Nagarjuna group. And he's a fellow member and a civil engineer himself. So what best to listen from you? So may I invite our National Treasurer, Engineer R. Srinivasan Garu, and our Hyderabad Center Treasurer, Engineer C. Ramesh Garu, to kindly felicitate sir. इतना सन्नाटा क्यों है भाई? कुछ हो गया है क्या? हाँ, बहुत ज़्यादा सन्नाटा हो गया। आप म्यूजिक ही प्ले कर दीजिए कम से कम, ताकि कोई तो आवाज़ हो हॉल में। Thank you, gentlemen. Moving on now, we have another important topic from Dr. Ong. He'll be doing the presentation on the topic designing for more resilient and less vulnerable buildings using performance-based design. I think personally, I would say this is one of the most important topics which we all need to concentrate on, because there's lots of vulnerability that's coming up to our structures due to climatic conditions, due to soil conditions, a lot of natural conditions that are really changing, a lot of volatility happening in the nature. So I think we need to hear it from Dr. Ong. Welcome, Dr. Ong. He is currently the director of AIT Solutions Asian Institute of Technology, and over 15 years of his professional experience, Mr. Ong has been involved in over 100 tall building projects. In these projects, Mr. Ong has led the structural engineering team of AIT Solutions and provided solutions and services in wind engineering studies, performance-based seismic design, one real-time structural health monitoring. He's also been involved in structural engineering projects from Philippines, Thailand, India, Sri Lanka, Myanmar, Pakistan, and Brunei. I think we have a very accomplished dignitary with us who will be talking on this. Thank you. Over to you.
Good afternoon, everyone. Today I will present overview of performance-based seismic design and concept. I'll focus mainly on the tall building design. architects develop the architectural concept together with structural engineers in close collaboration, as Engineer Majid mentioned this morning. After they sit together and discuss and develop the architectural form and structural form together, structural engineer needs to develop the analysis model to analyze the structural form or structural concept. So when we develop the analysis model, we have to capture the designated load path that we would like to distribute the load along the structural members. Our designated load path may or may not be same for gravity loading and lateral loading, like wind loading or seismic loading. So we may need to develop different types of analysis computer models to model the designated load path. Normally, engineers focus too much on the geometry of the model. But we should also pay attention to the load path, not only the geometry. In terms of structural systems, there are 5 broad categories. I will focus mainly on the lateral load resisting systems. The first type is bearing wall system. That system, when we do the design, we design those bearing walls to resist 100% of the gravity loads as well as the 100% of the lateral loads. So those walls has to carry gravity plus lateral loads 100%. Second type of lateral system is the building frame system. In that system, we have to design the gravity loads resisted by the moment frame. Lateral load, 100% of the lateral load is resisted by the shear walls. So in moment frame, shear walls are the main lateral load resisting system, and the frame is only for gravity. Another type is moment frame system. In the moment frame system, we apply the gravity, 100% of the gravity loads and lateral loads together on the moment frame. So those moment frames are designed for both gravity and lateral loads. And second last is the dual system. Sometimes we combine 2 structural systems, shear walls and moment frames together. When we use the dual systems in our lateral load system, we have to design the moment frame as a backup system. Moment frame should have the capacity, lateral load carrying capacity, at least 25% of the total design base shear. And also it has to carry the lateral load. It has to carry the gravity loads. And the last one is the cantilever column system. Those systems we do not use in the tall buildings. Those systems are used for the low-rise structures like car garages. So the main lateral load resistance is at the moment connection of the column with the foundation. When we further categorize the seismic detailing in the structural system, we have 3 categories. The first one is special detailing, which we employs the extensive tactile detailing to have the superior earthquake resistance. So we use that kind of detailing, detailed structural systems, especially in the high seismic zones. Another type is ordinary. Ordinary detailing, it doesn't have the extensive ductility requirements, and we use those ordinary detailed structural systems in the low seismic zone. The last one is the intermediate detailing. That detailing requirement, it provides the seismic resistance better than ordinary systems, but it's not as good as the special systems. These are some structural systems or concepts. In those pictures, the lateral load resisting systems are bearing wall systems. Some bearing walls, they are combined with the outrigger system to have the more lateral stiffness. These are sample dual systems which we use together, moment frame and shear wall system together. Let me briefly talk about the seismic design concept. Based on USGS information, there are about 500,000 earthquakes around the world, detectable earthquakes around the world every year. It is common to hear that earthquake severity in terms of magnitude in the news. In that location, there is a magnitude 5 earthquake, magnitude 6 earthquake, and so on. So what is the earthquake magnitude? Earthquake magnitude is a measure of energy release from that ground shaking. In the calculation of earthquake magnitude equation, there is a logarithmic function. So we cannot simply assume, let's say 1 unit of earthquake magnitude will not be significantly different. For example, if the magnitude 6 earthquake release, the energy, it will be 32 times more energy than the magnitude 5 earthquake. So we cannot say 6 is 1 unit higher than the 5. If we compare between magnitude 6 and magnitude 8 earthquake, it will have 1,000 times different and increase in energy. So we have to take care, we have to be aware that magnitude is in terms of the logarithmic scale. Another thing is the distance effect. Distance effect, it looks like when we drop a stone in the water, the ripples diminish with the distance. Same thing in the earthquake. If our building is located near the epicenter of the earthquake, the ground shaking will be very severe. But if the building is located far from the epicenter, the ground shaking will not be severe and damage extent will not be that large. So, although the magnitude is very large, let's say magnitude 7 earthquake happened, but if our buildings are located 200, 300 kilometers far from the epicenter, it may not have very significant effect. So when we talk about the magnitude, we have to think for the distance as well. Normally, structural engineers do not work directly with the earthquake magnitude. We are dealing with the ground accelerations as an engineering input parameters in our seismic analysis. Another effect is soil effect. When the earthquake happened at the hard rock soil, the shaking amplification will not be that large. But if the earthquake happened at the soft soil side, in that case, that soft soil will amplify the shaking when it reaches to the ground surface. Let's say the earthquake happened at the bedrock of 1 kilometer from the ground surface. But if there is a soft soil, maybe 50 meter or 100 meters soft soil, in that case, that soft soil will amplify the shaking, and when the shaking reaches to the ground, it is significantly affect, especially for the tall buildings. So, in the building codes, to consider that amplification effect of the soil, the code provides the factors to amplify the seismic forces. For example, if the building is at the soft soil side, the factor may be 1.2 or 1.3. So we have to use those prescribed factors to consider those amplification effects. In general, the building code's objective is to prevent the loss of life during the extreme events of earthquake. Their concern is mainly on the safety. Normally, building codes, when we use in the seismic design, we design for the one level of earthquake, what we call design earthquake. The code assumes that if we design for that level of earthquake, our building will not collapse under extreme earthquake, which may or may not happen in the lifetime of the building. And our buildings will be serviceable under frequent earthquake. We call it service level earthquake, not very strong shaking. But in the code, in the code-based design approach, we do not check those levels, extreme level and service level earthquakes explicitly. We just design one level of earthquake and follow the code's detailing rules, and we assume that our building will not collapse under extreme earthquake and it will be serviceable under frequent earthquakes. Let me explain how we design the normal buildings. In this graph, x-axis is the roof displacement. Y-axis is the seismic force, design seismic force. So, when we do the design for the normal buildings, we do not design the building remain elastic or no damage at all under extreme earthquakes. Because those earthquakes may or may not happen during the service life of the building. So if we design to remain elastic, for those earthquakes it will not be cost effective. So we allow damage in our buildings, but the building should not collapse. So, for example, let's assume that our building remain elastic under the earthquake, extreme earthquake. So the displacement and the base shear, they will be linear. If the shear increase, displacement will increase linearly according to the blue line. But we do not design that elastic base shear VE. In the code, it provides the response modification coefficients R factors based on the structural system that we use, depending upon the ductility of the system. So if we use the good ductile systems, our value is large, let's say 7 or 8, like special moment frame system, a dual system with a special moment frame. So we scale down the design forces with R factor. And then we design the base shear V, with the yellow circle only. But when the extreme earthquake happened, when our members, structural members, reach their yielding capacity, because we design only for V, so the structure become non-linear, and the deformation, force deformation relationship will be in according to the red line. So deformation increase significantly, the force will not increase significantly. In our code-based design approach, we normally use the linear analysis procedures. So when we apply the base shear V, we will get the small displacement with respect to V. So our analysis domain is only in the yellow region in our code-based design approach. But actual response of the building is, and the extreme earthquake, it is far beyond that. In the code, it provides us some prescribed factors to estimate the inelastic displacement to check with the limits. In American codes, they have the CD factor to estimate the inelastic displacement. And also, it has another factor called overstrength factor to estimate the maximum demand occur in the system. So that overstrength factor is coming from the overstrength of materials. For example, when we design the building, we use the nominal strength of the materials. For concrete strength, rebar strength, let's say we use the nominal rebar strength of 414 megapascal. But in reality, that rebar strength will be more than that when we do the laboratory test. Maybe it will be 1.2 times larger than the nominal strength. But we consider in our design only nominal strength. And also when we calculate the required reinforcement in our members, we have some safety margin. We use the demand to capacity ratio 0.9, 0.8, so 10%, 20% margin left. Not only that, we have the load factors in our design load combination. So those overstrength coming together. So when the structure members start yielding, but the curve is not flat suddenly. There is an overstrength in our system. That's why there is a force increase, which in the code it is estimated by omega naught. We multiply the base year V with omega naught to estimate the maximum probable forces in the system. Especially that those forces we use in the design of the important members like transfer system, transfer girder, and also columns supporting those transfer girders. So in the code we use a lot of prescribed factors in the inelastic range, the red line range, because we cannot analyze in the code-based approach. But in performance-based seismic design approach, we carry out the nonlinear time history analysis for the extreme earthquake. So we can simulate the entire building response under the earthquake, and we can check the building is safe or not using the reliable results, avoiding the code prescribed factors. For example, omega naught is 2.8 in the code, but it may or may not be 2.8 times larger than the design base year. So it may change. R value also in the code, it may be 7 or 8. Actual R value may be lower than that. So we can estimate our seismic demands in reliable manner. Between 1987 and 1994 in California, there are several earthquakes happened. So, structural engineers of Engineer Association of California, they developed a new framework called Vision 2000 to enable the engineers to design the buildings with a predictable performance, especially under earthquakes. So that framework developed a new design approach, which we called performance-based design. So in code-based design approach, we do not explicitly evaluate the structural performance for different levels of earthquake, and we have assumptions. Not only that, we have limitations in the structural systems. In the code, there are height limits for some structural systems if we want to use in the high seismic zones. And also, if we want to use the innovative structural systems, we cannot verify with the code-based approach. In performance-based approach, we can explicitly check the structural performance and the different levels of earthquake. Not only that, we can substantiate the code exceptions. For example, if we have the height limit for the application of for the particular structural system, if we can verify that system works well by performance-based approach, we can use it. And also we can use the innovative structural systems. And important thing is performance-based design is the cost-effective design. Here is an example for the structural systems mentioned in ASCE 716. For example, if we want to use the bearing wall systems in the tall buildings and in high seismic zones, we cannot use. There is a limit, 160 feet. We can build only 16-story building. So in that case, we have to use the other structural systems like dual systems with special moment frames. There is no height limit, so we can use in the high seismic zone. So if we develop the structural system for this tall building, if we follow the code-based procedure, we have to use the shear walls plus moment-resisting frame. But if we want to use only the shear wall, bearing walls, only with the flat slab, we can use PVD and verify it. But if the lateral stiffness of the core wall is not enough, okay, we may introduce the outrigger system to improve the lateral stiffness. So this is the comparison between the code-based and PVD approach. So in PVD, we can get the cleaner, flexible structural system, and also it will be, architects will be more happier in this system. And another example is in ASCE 7, if we have the discontinuous members which are supporting the discontinuous walls or columns, we have to use the overstrength factor, which is highlighted in yellow. So that overstrength factor is 2.5. So if we want to design those members, we have to multiply the analysis forces with that factor. But if we use PVD, we explicitly check the actual forces, so we do not need to use those factors. And also we can apply the innovative structural systems considering the dampers, like viscous dampers, coupling beams. We can use those innovative systems and prove with performance-based approach. In terms of cost effectiveness, if we do the code detailing, if we follow the code detailing rules, we have to provide the confinement in the boundary zones for all vertical bars may need to be confined with the red and the black ones. But if we follow the code, follow the PVD, if PVD results shows that our compressive strain in the shear walls are not large, we can relax the confinement. We may confine only the alternate vertical bars in the boundary zone of the shear walls. So by doing that, we can also save the cost. On the left side, it is quite densely provided confinement, and on the right side, it is confinement is relaxed. When we do PVD, we have to get more information compared to the code-based design. We have to engage other consultants. First, the structural engineers need to prepare the design criteria, basis of design of the building, which mentioned the description of the structural system, analysis procedures, performance acceptance criteria for different levels of earthquake. And also we have to, of course, we have to engage the geotechnical consultant who will provide us the soil properties, allowable bearing capacity. If we have the liquefaction potential, he has to provide us that information. If we have the basement, geotechnical engineer will provide the basement wall pressures. And also if we have our soil bearing capacity is not good, he will suggest the pile capacity varying with the depth. And the third consultant that we have to engage is the site-specific probabilistic seismic hazard assessment consultant. That one we do not need in the code-based design approach. For PVD, we need to engage that consultant to get the site-specific seismic input to be used in the design. So that consultant will determine the earthquake hazard and provide the engineer with different levels of response spectra for different levels of earthquake. And also the consultant will provide the ground motion records to be used in nonlinear time history analysis for maximum considered earthquake, extreme earthquake events. If the building is located at the soft soil site, that consultant will carry out the site response analysis and check the amplification effect. So they will analyze the soil, they model the soil nonlinearity, and then apply the ground motion. Let's say there is a soil layer 50-meter depth. So they apply the ground motion at the 50-meter depth and then model the soil column with the nonlinear properties and get the ground shape get the acceleration at the ground surface. So they can check how much amplification, what is the factor of increase in the acceleration. Based on that, they amplify the ground motion. So rather than using the prescribed amplification factors, we have more reliable results because soil layers will be different in that 50-meter depth. Some soils may be hard soil, some soil may be soft soil. So we can accurately analyze the soil information. The last consultant is wind tunnel consultant. For the tall buildings, wind tunnel test is also important. So that consultant provides us for the service level wind, normally 10-year return period for service level design, checking the story drift displacement, and another set of wind loading for 700-year return period for the ultimate strength design to calculate the reinforcement. And also it provides the acceleration check. Important thing is the coordination and understanding between those consultants. Who will do what and who will be the end user for that information. That is very important when we do PVT. Here are some guidelines, reference guidelines related to PVT. Normally, we use TBI Tall Building Initiatives guideline and LADBSTC guidelines, Los Angeles Tall Building Council guidelines. And also together with ASCE guidelines to check the acceptance criteria. When we do PVT, as I mentioned, probabilistic seismic hazard assessment needs to be conducted. So PSHA consultant carry out the analysis for the seismic sources, normally around 400-kilometer radius from the project site. Some building codes do not consider that probabilistic seismic hazard assessment, like UBC 97, they use the zone factors instead of PSHA information. And by doing that PSHA assessment, we can identify the dominant fault for different levels of earthquake. And also uncertainties in the seismic sources can be explicitly considered. Here is the example checking the dominant fault. This deaggregation analysis is for maximum considered earthquake. So let's say near the building there are 8 faults. And the fault A, when we check the peak ground acceleration and spectral acceleration at 1 second and 3 seconds, from the analysis, fault A is governing for the MCE level earthquake. So when we select the ground motions for the analysis, PSHA consultant select the ground motions which have the same characteristics with the fault A. So the ground motions will be obtained from different various sources from internet. For example, if we do the project in Philippines, but the ground motion will not be coming from the Philippines, maybe past earthquakes in Taiwan or US, but they have to check that ground motion is generated from the fault which has the same characteristic. This is the deliverables, one of the deliverables from the PSHA consultant. They give us the response spectrum curves for service level earthquake, which is the green one, 43-year return period. The middle one is the design earthquake, which is 2/3 of MCE. The largest one is 2475-year return period earthquake. When we do PVD, there are two objectives. These are basic objectives. We have to design the building for service level earthquake, and the building should be serviceable and after the earthquake. So very minor damage in the building. The building will remain elastic. And another earthquake is maximum considered earthquake, which has 2475-year return period, and we design that the building should not collapse, and that earthquake partially or totally not collapse, but may or may not be repairable after the earthquake. So these two objectives we check explicitly. So because of the extensive damage allowing extensive damage in the MCE earthquake, we have to carry out the nonlinear analysis. This is the general BVD procedure. After carrying out the geotechnical assessment, we have to provide that geotechnical information to PSHA consultant, and PSHA consultant carry out the assessment and provide to the seismic input to the structural engineer, and structural engineer use the schematic design, determine the member sizes, and then after doing the schematic design, structural engineer can get the model analysis results. That model analysis results information will be conveyed to the wind tunnel consultant, who will use for the wind tunnel testing. After getting the wind tunnel loading, structural engineer carry out the wind and service level earthquake design. Normally we call it elastic design because the building has to remain elastic in those loadings. Then, after getting the elastic, the reinforcement information from the elastic design, we have to conduct the MCE nonlinear evaluation. I also mentioned the approximate duration of each task. It is a lengthy process. So, the initial design, in the elastic design, for the wind and service level earthquake, we have to check the reinforcement using the linear analysis procedure. And then we have to create the nonlinear model using that reinforcement and evaluate the MCE response. In MCE response, we carry out the nonlinear time history analysis for 11 ground motions. 11 pairs of ground motion. Each pair consists of X and Y component of the earthquake. We use 2.4% constant modal damping with small amount of relay damping in our nonlinear model. And generally, we use average of 11 ground motions results. So to create the nonlinear model, we have to input the force deformation relationship of the structural components. For example, this is the moment rotation curve for the beam. X-axis is the rotation and y-axis is the moment. So after reaching the yielding moment capacity, the deformation will be increased, and then there will be strength loss. So that force deformation relationship will be developed from the laboratory test. People test the members under cyclic loading and get the force deformation relationship. This is the sample test results of conventional reinforced beams. So you can visualize in that rotation 0.06 radian what will be the extent of the damage. Normally when we do the code-based design, we deal with the force. We analyze the building and get the force demand, moment demand in the beam, and then calculate the longitudinal reinforcement required. But when we evaluate the nonlinear response, we have to classify the responses into two categories. One is deformation control actions for the responses which has the tactile behavior, like flexural response in the beams, flexural response in the shear walls. So after yielding, after reaching the yielding capacity, flexural capacity, it will not suddenly lose the strength. It has some ductility. So we consider those actions as deformation control actions. And second type is the force control action. Force control action means the brittle actions, like the shear response in the beams or walls. They are very brittle, because if we reach the shear capacity, we lose the lateral load or gravity load carrying capacity suddenly. So types of analysis and check with the strength capacity. So how we can get the deformation capacity? Force capacity we can calculate based on the provided reinforcement from wind and SLE demand, and we can revise if needed. But deformation capacity, if we provide that reinforcement, will be the rotation capacity. It is difficult to calculate. So where can we get? We can get from the ASCE 41 guidelines and other documents. They provide the acceptance criteria and modeling parameters for the they have the tables for the beams, columns, so we can use those parameters. In the red box, they have the backbone. The ABC is the backbone curve parameter. It is the capacity, and CPLSIO. This is the acceptance criteria. If we would like to check the performance and for collapse prevention, our beam rotation should not exceed 0.05 radian or 0.04 radian and so on. So we can use those guidelines for the acceptance criteria. We can also use the nonlinear fiber models in the shear walls, mainly in the shear walls, to model the flexure behavior. We can consider the confined concrete stress strain curve and confined concrete stress strain curve, and also rebar stress strain curve in details, and we can check the stress and strain in each fiber in the nonlinear analysis. Another important thing we have to consider is the backstay effects in our tall buildings. If we have the large podiums, there is another load path, secondary load path called backstay load path. The overturning moment due to lateral load is resisted by the in-plane stresses in the slab diaphragms, in the podium and the basement floors. So that backstay load path reduces the overturning moment in the foundation. It is good, but it will also increase the in-plane stresses in the slab diaphragms, and we have to check the stresses and provide the diaphragm reinforcement. To consider to have the conservative design, we have to bound the results. Normally, we bound the in-plane stiffness of the slab diaphragms for the upper bound 0.35% in-plane stiffness modifier and 0.1 in-plane stiffness modifier. So for the foundation design, we use the lower bound in-plane stiffness to have larger overturning moment, but for the diaphragm design, we use the 0.35 in-plane stiffness. And these are sample acceptance criteria for the nonlinear evaluation. We check the peak transient drift of the tall building, which is average drift limit is 3% and individual ground motion limit is 4.5%. Not only that, we have to check the residual drift. Normally, we do not check the residual drift in code-based design. In tall buildings, it is important. Residual drift is a permanent drift after the earthquake. If the building is tilted significantly after the earthquake, not only that tall building itself, the neighboring buildings are also in danger. So we have to limit the residual drift. So The average residual drift limit is 1% and maximum drift is 1.5%. And also it has, I mentioned the strain limits for the shear walls, flexural rotation limits for the beams. But for the force control actions like girder shear, mat foundation, flexure shear, diaphragm, in-plane responses, we design to remain elastic. So we have to get the force from our analysis and check the reinforcement. An important thing is the interpretation of the analysis results. Because when we conduct nonlinear time history analysis with for 11 ground motions, very huge data is coming. We have to interpret the results to have the meaningful design decisions. So first we normally check the global responses like base shear. We compare the elastic base shear, which is yellow line, and the nonlinear base shear, which is the green one, and also the red one is the service level earthquake. Service level earthquake is the lowest. So we have to compare those base shear values. Normally, nonlinear base shear is lower than the elastic base shear. And check the transient drift along the height of the building. The red lines are the limits. This is the residual drift plots along the height. And we check the axial strains in the walls. This is the sample axial strain results at one corner of the wall. We have to check every corner of the wall and plot and visualize the results. For example, here left side is the compressive strain result. X-axis is the strain value, y-axis is along the height. So we can see that it is well below the strain limit of concrete crushing strain limit of 0.003 for unconfined concrete. The right one is the rebar tensile strain. We check with the yielding strain, and also the actual rupture strain is 0.05, which is quite far from this. Okay, so here we can see that in one ground motion shear wall is yielded at the ground level. And also we can see at the upper levels also they have larger strain, tensile strain values. Normally the bending moment is largest at the bottom base of the wall, but because of the highermost effects of the tall building, the bending moment is also high in the upper floors. This is the coupling beam rotation, this is the shear wall shear check. We extract the shear force and check each leg of the shear wall and plot with the capacity. The black one is the average demand. This is the coupling beam rotation along the height of the building. The rotation limit is 0.05 radian. And I want to share some challenges. I'm about to finish my presentation. In PBD, when we do the shear wall shear design, normally the shear demand is larger than the code-based design results. So we have to make sure that the shear wall thicknesses are adequate. And another important thing is the diaphragm design, especially at the ground floors and transfer floors, mainly at the ground floor. The forces coming from the tower shear walls transfer the forces to the basement wall with the ground floor slab. So we have large in-plane stress demands, and if we have the isolated footings under the walls, in that case we may encounter the large uplift demands. We have to carry out the nonlinear uplift analysis in the foundation design. And also if we use the outrigger columns, we have to check sometimes because of the vertical earthquake effect, we have some issues in the axial compression capacity of those columns. So we have to negotiate with the architect, and if we need to, if we can provide additional walls or other load part, we have to provide them. One last thing is the important thing is the peer review. We are doing beyond the code, so someone needs to check whether our work is correct or wrong. So peer reviewer needs to carry out for the PBD design. Not only that peer review process helps exchanging the ideas between the designer and the peer reviewer, and it will improve the body of knowledge. And we can also, most of our knowledge in BBD, we learn from the peer reviewers. And we have to develop the comment log. Peer reviewer develop the comment log, and engineer of record has to respond their comments. Those comment logs in our past projects are very valuable assets. These are like a knowledge bank. If we want to find the solution in future project, we can have a look in what are the solutions how we solve the problems in the old projects. So these comment logs are also valuable for us. So this is about performance-based seismic design. Thank you for your kind attention. I want to share one thing. In AIT, we offer the professional master program for structural design of tall buildings. This program is tailored for the practicing structural engineers. It is a hybrid program, so the engineers do not need to leave their job while studying. It is mostly online, but the students have to come to AIT at the end of every semester to sit an exam. So our faculties, theoretical knowledge and their extensive practicing experience, we developed that program for the practicing structural engineers. If you want to have more information, you can get that information from our booth number 17. Thank you very much.
Thank you so much, Prof. Strong. That was quite an interesting talk on how synergies have to be built to mitigate further risks. And I think it's time for us to wake up and see that we all combine our forces and intellect for building a safe building community. Thank you so much. Now may I request ACC founder member, Engineer Umesh B. Rao, and Hyderabad Center MC member, Engineer C.H. Narmada Garu, to please come onto the dais to felicitate Professor Ong. Thank you so much. And if we are a little more tired and need to refresh, let's all go for a small tea break. It's about 4:40 in my watch, so we will come back by 4:50. Sharp 4:50 please, because we are running a little late. So let's try and get those 5 minutes smaller. Thank you. tea break is over, and I request everybody to please settle down fast. All the delegates in the tea area, please come back and join into the hall. We're starting the session. Please get your tea cups inside. Alright, the next session we have Project Management and Construction Technologies for Tall Buildings in Thailand. And to take us through this topic, we have Dr. Naram with us. May I request Mr. Naram onto the stage, please, for the presentation. He is currently the chairman of Future Engineering Consultant Company Limited, Thailand. He is also emeritus professor of Khon University, Thailand, and adjunct faculty in Professional Master in Structural Design of Tall Buildings program of Asian Institute of Thailand. Dr. Naram has about 28 years of experience in project supervisory and advisory role in structural and civil design construction projects. The project that he has been directly involved in high-rise buildings, parklands, hospitals, commercial and office buildings, industrial structures, transportation infrastructure, and development of master plans. He selected projects like these are the project design for BTS SkyTrain Station at Bangkok Island, BTS SkyTrain Station, Office of Transport and Traffic Policy in Thailand, Master Plan Physical Design for Rajghat University in Thailand, Construction Supervision and Management. He's done quite a few projects. He's been a project engineer for the 93 condominium building Vitun Holding Company in Thailand, and the list goes on. So now, without wasting much time, I would request Professor Naram to take over and run us through his presentation.
Thank you. Good afternoon, everybody. Since this morning you listen a lot related with the how to design. Now, we will join together to make the dream come true. The question is how to get things done within a time limit, within the scope of work, in a limit of budget, in a certain level of quality. Today I will share with you the point that I want to share today is I want to ask you something. During you supervise or construction management your job, your project in India, do you have any problem? Can you tell me some? Okay, if you don't tell me, I want to tell you that from the starting point, you may start with pre-construction period. You have to prepare many things. And you have to, after finish for the pre-con period, you come to the construction period. So, the first thing that you have to do is the planning. How do you plan? How to get things done? You know already. But I have some problem, some 10 points that I want to share with you. It doesn't matter if the low, tall, medium tall, or super tall, or very tall building, or the low-rise building. Do you have a problem related with the neighboring building that they complain a lot? This is the key thing that I want to address with you. How to deal with this one? Mostly, even though you have the design that very good, but it still have some problem. The big thing is the vibration of your equipment. For example, if you start with the boring ball pie, for the ball pie you will get many things related with this kind of thing. Okay, I will discuss with you step by step. For this presentation, I will show some example of NATCON building is the super tall building, okay, and some tall building, not only the hospital, not only the condominium, but also the office building and government building, okay. And also I want to share with you some quite new project in Thailand now. It's a One Bangkok project. It's a big project that have a variation of problem and variation of function. Of course, all of you know, if you want to be success, we have to apply, we have to initiate many kind of knowledge. The first thing is construction management knowledge, okay? However, most of you, I think you know this kind of thing from the PM box, body of knowledge of PMI. The first core function of the construction management concept is you have to deal with the scope management, how to manage your scope, how to manage your schedule, your time, how you manage your cost, your expense, and finally the customer expect from you is how to manage the quality. This is the core concept. The second group is if you want to get things done, you have to know how to manage your staff, your engineer, your architect, and your labor. Of course, you cannot do by yourself. You have to do as a team. You know the team building, right? Team building start with the forming. When the team form, you will become stronger. I give you 1 month enough. You have to settle everything and go together. Okay? This is the communication. And you deal with many risks. You have to know the risk management. And of course, if you want to get things done, not only management but also the material procurement, you have to know the how to procure in appropriate way. Okay? And of course, one thing that very important is you have to know who is who in your project, internal, inside your project, external, outside your project, not only outside in your company, not only outside in your big group of company, but also the management outside the local authority and many things. So this kind of thing that you have to know, the stakeholder management. In my opinion, stakeholder very important for the success of your project. Of course, you cannot be finished without the safety regulation. Most of the law enforced by government. They ask you to do many things around how to control the safety, how to manage your environment for the construction site, and without the financial concept, you cannot finish. I want to inform you that the bankrupt company not come from no job to do, but come from the cash flow of the project, of the company. So this is very important thing. And every project, you face with many claims from any people around you. Okay? This kind of thing that I want to address, but I don't want to go into detail because most of you know this kind of thing. But one thing that quite different between tall building, super tall building, and ordinary building is the planning technique different. For example, this one. When we plan for the tall building, we will plan in vertical planning. You can see that the red one is the structure. The second is architect, mechanical, electrical, plumbing, interior, and so on. From this one, you can go to the line of balance technique to manage your properly. I think all of you know this kind of thing. Okay? I will tell you something that when I face with the problem, for example, difficult to manage because we use a lot of material and most the construction site in the center of the building, very crowded, very traffic jam. How to manage this kind of thing? You have to pre-planning for your construction site. I think you know this kind of thing. But I want to show you one thing that for the soil investigation and change to the basement. And before basement, we have to start with the piling technique. Before we start piling, we have to check with the what is the basement, how many floors of basement, something like this. We have to concern about the surrounding that I discussed with you. I faced the problem when I supervise the petrochemical plant expansion project. We cannot violate anything. We have to control. They can pay. How to do with this kind of thing. I think you know this why it can control the vibration. For example, with the ball pile. We can control the vibration also that I want to share with you. I think some of you know this kind of technique. For conventional method in the left side and the innovation method, almost zero vibration, can be easy to control by using this technique, double casing. This kind of thing that I implement to solve the neighboring complaint in my country, in Thailand, and in the petrochemical plant that we don't want to make the plant back up, back down. Okay? This is the technique that I want to share with you. The thing that I want to share with you today, not only the new technology, but I want to share the appropriate technology that fit with your cost, fit with your culture, your equipment. Okay? This kind of thing also. How to manage this kind of thing? We prove from the testing. If we put the two double casing, we put the vibration sensor. Can you see? The blue one is the double casing, but the triangular one is the conventional method. You can see the difference almost 7 times. So this kind of technique, I think some of you know. I will not go into much detail. However, for the tall building, super tall building, mostly we will have to build the basement also. For the one Bangkok project, they built 5 basement, 5-story basement, very deep, 22 meter depth. So not easy. In Thailand, we have many problems related with the soil condition also. We have to implement the D-wall, diaphragm wall. And because it's quite big, how to manage, how to construct properly. Okay? I will go to the next. You know the technique to work with the diaphragm wall or D-wall. The green line is the D-wall of this project. And because it's too big, we cannot pour in one time. Okay? We will separate in each area by using the pivot. You know also, in my opinion. So this kind of technique can help you to pre-planning for your construction, for your planning. Okay? However, during we start to build the basement. How can we do? For example, this building. Okay? For the substructural package, we will build 5-story. The depth approximately 22 meter depth. For the normal tall building, after we set up the platform, we can use backhoe to move the earth. But this one is quite big, 166 square meter. How can we do? We put it is the normal, all of you know, platform, quite big platform. Okay? We have the D-wall and we separate in each part to start by using inter-pivot. We start with the first portion. Okay? This normal, you know. Only that how we divide in each portion, each phase of this one. Okay? So you can start phase by phase. Not so easy for the people who can plan for this thing. They have to have the experience. They have to know the condition of many things. They have to have the expertise, the advisor, especially the soil engineer, the geotechnical engineer to help you. This kind of thing. So you can see, if you see this presentation today, I think that you can bring back to implement in your project in the coming year. Not long, here we will implement the super tall building, in my opinion. But not only in this area, but also along other area. Okay? This is what I want to share with you, that we can manage. If it's quite big area, we have to manage. Each portion, the mat foundation, 22,000 cubic meter of concrete. We have to pour 36 hours. So not so easy, but we can do. The engineer can do everything. This is what I want to share with you today. Okay? From the basement, after we finish, This is what have been done. Please be informed that. During we prepare the shop drawing for every discipline, structural, architect, MEP, we have to combine together. This project we apply the BIM Revit to use for combined shop drawing. I think that in India you apply this kind of thing also. Okay, I will discuss with you. The main problem that you may face is when you open the big area, the underwater may come, the rainfall may come. You have to have the dewatering pumping station. You have to calculate everything, how to pump out, how to manage this kind of water. When you pump this kind of water out, you have to make it more clear without the soil, without the thing that make the authority, the local authority make you not happy. Okay? And the second thing, when you move the earth out of form, you will face with the groundwater and uplift pressure. How to manage this kind of thing also? You have to discuss with Professor Jack or some specialist expert in this area to put the seismometer. Okay? Seismometer can help you to control the uplift pressure and groundwater. Okay? This kind of thing you have to consider also if you want to build this project done without the key, the big problem. Okay? This is what it looks like at night. Not so easy, quite big. 166,000 square meter project. Okay? When we move the earth out, we have to have the technique also. Your expert have to support you how to do with this kind of thing. You have to discuss with the designer. You have to discuss with the expert in this area. Soil engineer, geotechnical engineer, many people. And during you move the earth out, you have to apply some technology because you move this earth, this soil we move 2 million square meter. No, not square meter, cubic meter soil out, not easy. We have to use this kind of thing, telescopic. I recommend to you also because it's very deep, 22 meter depth. Okay, this kind of equipment can help you to solve one pickup, 1 cubic meter. Okay, so this kind of thing, I think that all of you can collect some idea and use for your project. When we pour the mat foundation, only one portion, 22,000 cubic meter concrete, we have to finish in 36 hours. How to do? Very important, many projects that we have been done in Thailand and we want to share with you. This is the appropriate technology that, in my opinion, and AIT solution, think that we want to share with you. You may have another option. This is the one option that quite interesting. Okay? This project also 22 cubic meter concrete to pour. Different super tall building also this kind of thing. The very important thing is the next important thing for the super tall building or tall building, very tall building, is the how to move the material from the ground floor to the certain level that we want to use, we want to build. The material handling and mechanization very important to deal with you. You have to have some expert for equipment, vertical equipment to support you, how to calculate the number of each equipment. For example, this one, not tall, this one, it's 34 story, not much, around 100 plus, okay? But we have to plan many things. In the limit of area, you can see that the area not much. We have to control. This concrete pump, very important. We have to find the appropriate technology that can fit with our project. Not only one, but we invest 4 of them. We cannot let them broken. And you can see the point for construction time use TPU. We have to move the labor, the staff every day, at least 1,000 of people. We have to move the material. So how to calculate the point? Otherwise, for the super tall building, the height is around more than 300 meters. Move up and evening or afternoon move down, that's you lost time. We have to calculate this kind of thing also. You can discuss with the expert, equipment, construction equipment expert, this kind of thing. Okay? So, the next that is one element of the tall building is how to pour the flooring and the wall. The goal of this project, we need only 1 floor per week. We don't need 2 floors per week because it costs too much. We call the appropriate technology. Sometimes lucky we can make it 5 floors per month. It's lucky. Okay, but average, in my opinion, 1 floor per week enough for the concrete, reinforced concrete structure. Okay. However, if the span a lot, some designers they implement beam and slab because they need the stiffness of the beam. Okay. However, after discuss with the designer, we can change to the biaxial slab. This is some technique that can help you to deal with this kind of problem, this kind of pain point in construction site. Okay? So, I think that you know something that can be applied in your project. However, if you need to finish 1 floor per week, you cannot use normal scaffolding and formwork. You have to use the appropriate one. This is what we do with this kind of project. You can see that one worker can install the scaffolding and formwork, not so heavy. Okay? This one also, we have many kind of formwork that proper for the tall, very tall, super tall building. I saw from the exhibition people that they use aluminum also. This, we use aluminum also. It can be used for the super tall or very tall building. So we can discuss with the supplier, with the vendor, who can help us to implement, to manage properly. Okay? Today we discuss the appropriate technology. The next element that very important for the super tall building and very tall building is the core. You have to use the solid form. For external column, for the superstructure, very important. We have to implement special kind of solid form. Not so many companies can do this kind of thing. Have to be precise. You have to consider how to apply to implement this kind of thing. Make a column solid form and lift and stair called solid form. You have to manage and find out the expert people to support your project to be successful. Come to the external cladding. I go a little bit fast because I don't want someone to force me. Okay? And I think that all of you want to go back now. I will show you something. For the external cladding, it's easy for you. I will not talk too much. But one thing that I want to let you know, how to manage the safety, how to control the dust, the environment problem, how to set up the procedure to build parallelly in schedule that I showed to you at the first time. Okay? You can see that during you construct each floor, you can go by using this one. The mist area. It is a little bit technology. We use the jacking to jack up and control only 4 story and move up. We can control the dust and the falling only this time. Why we apply something like this? Because we study that, some project, they have no choice. They have to implement something that they can work parallelly. Not only the structure, but also the cladding. Okay? But Khalifa also do the same technique we study from this project to implement in that project. Okay? So this kind of technique, this kind of idea can help you to plan properly. Okay? And you know the cost. You can find the data from someone. Don't worry if you cannot find. Contact AT Solution Director. He will find the data for you. Okay? This is what we want to share with you, that this is the appropriate technology that fit with the Asian country like us in a limit of budget. Okay? You can see, not so difficult for the roof of the tall building and super tall building. It may come special case because they need to use this area very premium price. So how to deal with this kind of thing? And we have to set up many equipment, both during construction and during maintenance also. We have to think a lot. So discuss with the owner, discuss with the maintenance team, discuss with the designer to set up all kind of equipment in the roof form to prepare for any condition in the near future. Okay? You can see that what we have been seeing not so difficult if we know in advance. That's all. Okay? more easy. This building quite high. They design in concrete structure to make the facade difficult to pour the concrete. So we have to change to the steel structure. Of course, everything more flexible and more easy to install. One thing that I want to share with you today is the beam technology. You cannot deny. Some of you implement already. Without this tool, it may make some problem for us. The beam technique that we implement in the construction project, we want to build in the computer before we build in the real site. When we build in the computer, we can take a look of any clash we can solve before we construct at site. I want to let you know that most of you is the consulting firm. Myself, in Thailand, not so many contractors that if they implement the BIM. I have to promote by, I implement, I ask my team to prepare the BIM for them. I invest because I don't want my project have some problem. After 6 months, they say that, oh, very good, very good. I ask them to share the cost with me. They're happy to share. And after that, I give them to start to implement in his company. This is, I want to share with you that we are the consulting engineer. We have to get things done. If the contractor cannot perform properly, we have no choice to help them to be success. If they not success, we not success also. This is the key thing. Okay? When everything, structure, architect, MEP can combine together, you can see many class. This building also, we implement mostly when I work in Thailand, I implement almost every building. Okay? We have the class report for both major and minor class. We discuss, we have a BIM team to discuss for the class and how to solve. We have the report. And after we solve the problem, we have before and after to show to the owner also. They're very happy. Trust me. Not only the owner happy, you are the consulting firm. You have to get it done. You have to know and you have to help them. This kind of thing can make the project success and can raise up your reputation. You can show to the owner. From the BIM like this, when we build like this, very similar. And we can use this kind of BIM for FM also, facility management. Okay? I just want to show that some of you implement already, but I think that very important for you to do in your job, especially the consulting firm. I think you familiar with this kind of thing, some of you. We can combine between 3D and the schedule also. Link with Microsoft project, link with Himawila, P6, something like this. So, I hope most of you will implement soon. Some of you may implement already. Okay? Very serious thing that I want to tell you is nowadays, without the green building, you may lose some job. You have to know what is the green, how to implement, how much it costs, something like this. Okay? Of course, for the green building, lead original by lead from US and distribute in every country. I think in India you have your green building also, right? So I suggest you that try to implement. The cost not much in my opinion. I try to check the cost maybe around 5 to 7% of the project cost. But it makes a lot of things. Why make a lot of things? Because resource efficiency, indoor air quality, very good indoor quality. I want to tell you, if we follow the concept of green building, energy efficiency, 5 to 7% that you spend, you can gain after that. Water conservation, affordability, this kind of thing is important for the people who live in your project, in your building. Of course, this kind of thing, you don't need to go to platinum. You can go to allow gold enough. When I implement, I recommend the owner go enough. Not much investment. Okay? The important thing that I like to share with you today, the appropriate technology, the safety, security and environment. Simple. We try to implement in Thailand also. Not 100% that we can apply. In Bangkok, only half. But in a certain area like the industrial estate, oh, they serious a lot. When I supervise the power plant, the refinery plant, the petrochemical plant, when we celebrate 5 million man-hour, no serious injury. That's thing that we celebrate. Success is that, oh, we have to success. So I want to share with you one thing. Control the environment, cleaning, training, how to control the fire. Every day we have the fire people, but we have to train them to control the fire. We have to know how to train them. Sometimes we want to check the blood. Morning talk, very important. Everything, temporary structure, very important. We implement safety talk every morning. We have to have the safety award to let them know that the management team serious with the safety and quality of the email of his team. Even though this picture, I work in Myanmar, I also sit in front of the labor, thank them that you work safety. Please maintain this kind of thing. We don't want to lose any people, okay? Not only the safety but also security. During COVID-19, we control also. For the big project, not only the normal, we have to control the dust, the lighting, that let them work properly. Sometimes, not sometimes, we have to control the CCTV to see who enter in our project. Okay? Control access, use face recognition. We check the drug, the alcohol, the lifestyle. Every equipment we check every half month. traffic training, clean the area, clean site before the equipment out, we have to clean everything. So I want to conclude like this. If we want to be success for the tall building or super tall building, we need to have the project management concept, the contract administration, the construction site operation, digital technology, and related area in green building, safety, interpersonal skill, and BIM. I don't want to talk too much related with the interpersonal skill, very important. We getting done by the other, the project manager, so we have to know this kind of thing. Any question?
Thank you, Professor Naran. I think as much as the doctors deal with human life, so much so does the architect and civil engineer deal with human life. I say so because the staff, the people employed at site, they are our assets, and their safety is of prime importance. We do not want to lose people. That was one fine statement made by Dr. Naran, which actually caught my attention. We really don't want to lose our professional people, our brethren, to accidents at sites because of just some careless attitude. So I think project management is not just about monitoring quality and timelines, but it's also providing safety to all the people working at sites and seeing that we take our project forward without any casualties. So thank you so much, Dr. Naran, for this wonderful presentation. And now I request founder member of ACCI, Dr. Garuda Charan, to please come on to the dais, and ACCE Hyderabad Center MC member Engineer Balram Garu, please, to felicitate our speaker. So can we have you center stage, please? Thank you, gentlemen. Now time for a small commercial presentation. Our sponsors, Mahalakshmi Profile Limited. Can I request them to please come onto the dais? Any representative of MPL is available here, please? Okay. So nobody from MPL is here? Okay. If there are any representatives from my home, please be ready for the next presentation, or otherwise we will carry on with our sessions.
Change it. Slide. So, good evening one and all. the present delegates, the civil engineers, architect engineers, professors, students and all. So I'm representing MPhil Steel Pipes. First of all, I'd like to thank you, the Association of Consulting Civil Engineers, for giving MPhil Steel this opportunity to present my company before you. So without much delay, I started the presentation. So before going to the formal presentation, I would like to just let you go through this famous, quotation by the eminent architect Lee Corbusier. The metals of the city planning are sky, space, trees, steel, and cement, in that order and that hierarchy. So I'm representing steel, and we are a part of this modern era civilization. And the modern civilizations are heavily dependent on steel. The agenda. So we are a 64-year company established in 1959. We are the first steel manufacturing plant in Telangana, and we are just growing strong year after year. And with a humble start, right now we are clocking around a corporate turnover of 1,500 plus crores of revenue per annum. We are driven by a very talented and highly skilled young professionals of 2,500 people are with us. We are a business conglomerate of various businesses like cement, investment, leasing, and logistics, apart from steel manufacturing. So what defines us? What defines a company? What defines MPL Steel? So this is our vision statement: to be leader in the steel tube industry, empowering the people through value creation, achieving sustainable and responsible growth. So, this is a vision statement which we want to drive ourselves to be a global leader in the steel manufacturing in years to come. So this is our mission statement. To go forward to achieve a vision, you must have a mission statement. It's like, driving to your vision. So we are committed to manufacture cost-effective steel tubes through quality leadership, teamwork, effective utilization of resources, and innovation for the mutually beneficial relationship and customer focus. So our focus is customer. We always believe in our customer to deliver to their expectation. So these are our core values on which MPL Steel Pipe rests above: customer-centric approach, integrity, commitment, excellence, and sustainability. So before going forward, I would like to just put light upon the Indian steel industry. What do you like, and what is the scope for, the pipe industry in future? So India is currently manufacturing around 132 million tons of steel. If you just calculate per capita, it's 76 kg against the world average of 233 kg. So we are not even 1/4. So there is a way forward. It's like more steel to be consumed to even grow in the modern era. And if you just drop down to per capita pipe consumption, so it's very negligible, not even 10 kg per capita, against the world average of 24 kg, and the China stands at 55 to 60 kg per capita. So if at all we have to achieve a world average, then also we need to grow by 2.5 fold. So there is a huge scope for the market, and right now the Indian pipe market is around 60,000 crores roughly. So we need to go forward to achieve 1.5 lakhs of crores of market to at least achieve the world average. So steel pipes are known for their versatility, obviously high strength to weight ratio and aesthetic appeal. And of course, it's a sustainable alternative to wood, because right now everybody is talking about sustainable building solutions, negative carbon footprint. So steel is a best alternative to that. Yeah. So before me, eminent speaker, Dr. Lim Boon just told us what is the best practices they're just adopting in Bangkok. So this is somehow related to that, because we are just requesting our civil engineers to, when you are just going for piling, don't just go for an open piling or just blasting the side and do the foundation work. But instead, you can go for with using the steel pile foundation method, in which it not only just reduces the turnaround time of the project, but also gives you a better solution. You can say building solutions. So penetration through hard layers, as the Hyderabad is a hard terrain, mountainous terrain, rocky terrain. So this is the best solution for that. Reduce earth removal and vibration. Customizability, because steel is easily customizable. High bending strength, strong and durable foundation, and ease of handling and transport. So these are the things which make steel a favorable choice for any project. And before going to the slide, like nowadays cities are growing vertically. Like as the context of this meeting, like building tall and resilient. So what happens whenever you grow vertically? So it brings in more responsibility and more concern about the safety. Because when you are living in a 100-meter height, so your safety is a bigger concern, and the major concern is fire. So the best solution to your fire safety is the fire hydrant installation, which is the best solution you can do with the MS steel pipe. So it is high fire resistance, durability and longevity is very high. Structural strength, because when there is a high rise building, the water pressure is very high. So to endure that, you need a proper structural strength steel pipe for your application. Ease of installation and cost effectiveness, of course. So the steel pipes are very cost effective to its counterparts. So there are some of the multiple applications like seismic retrofits, scaffoldings, structural column, trusses, foot over bridge, and vertical car parking. Yes, this is one of my favorite slides. So like steel pipes versus conventional structure. Why steel pipes? Why not normal angle channels? So this is a comparative analysis. Like if design features is concerned, the torsional rigidity is excellent in the steel pipes compared to the structural steel applications. Bending capacity is excellent in steel pipes. Buckling, of course, we are good. Compressive strength is also excellent in steel pipes. And if you go to the project features, because nowadays everyone calculates what is the money, how much I am saving in my project. So overall cost is excellent in steel pipe. Build time is very good, because in the COVID time, the modular building solution is in Delhi there are so many hospitals are being made overnight. Means hardly the turnaround time is 30 days to 45 days. So in terms of tonnage, excellent strength to weight ratio, so 10% saving is a must, the normal counterpart of structural steel. Scalability, as it is modular, it is easy to install. And wastage, of course, it's minimal, because you can just order cut to length. So these are some aesthetic application of steel pipes and tubes. Yeah. So what we are offering to you, as a steel company, what we are offering to you. So there are 450 plus sizes of steel pipes to cater to 4,000 varieties of application of yours. So if you have a dream, if you have an interest, if you have an architect mind, then you have a solution here. So before going to your doorstep, our steel has to go through 40 plus quality checks. So we are not only giving a good product, but quality assured product. So we are also giving all 210 wire steel, 214, 310 and 350 grade steel. And we have a very strong dealer network all across the country. So we have 2,000 dealers, and if you have an idea, you want a fabricator, we have 30,000 plus star fabricators in our list. So you can come to us, we can give you a solution. So there are some quality check techniques we are adopting at our plant. Yes. So we are complying to all the Indian standards, like as per your requirement. So there are some integrated management system certificate we are being awarded from TUV North Germany. Yes, we got approval from some of the prestigious government institutions like South Central Railways, Telangana government, Central Public Works Department, and Hindustan Shipbuilding Limited. So we are not only just present locally in India, but we are global. We have a global presence. So there are some countries we have already exported our product to. Yeah. So before concluding, look around you. if you found some steel structures, it might be of NPL steel pipe made. So build your dreams. Where there is steel, there is a way, and where there is NPL, there is also a way. Thank you so much.
I think we really like your quote which says, wherever there is a way, there is steel. So, short of time.
Thank you so much. Thank you.
So, may I request Chairman Engineer Kashiram Garu and Engineer Jayaprakash Garu to please come over for the felicitation. Any questions or any clarification on the product? I think the speakers, the vendors and the company guys are all around. So during the networking or during lunch or tea breaks, you can always catch up. Thank you, gentlemen. And after a long day of so much of learning, we have one last session for the day. Thank you all for the patience that we all are in full capacity in the hall and still enjoying the sessions. So one last session, let's have some more patience. And this is about the topic Building Information Modeling Application in Tall Buildings. The speaker is Mr. Darshan Ruikar from Arup Consultants. Welcome you, Mr. Darshan, onto the dais. Mr. Darshan is Arup Advisory's lead for BIM, digital and data management, boasting over 20 years of expertise in executing BIM and digital transformations across diverse sectors. His proficiency covers BIM advisory, data management, digital product development, regulatory monitoring, and data governance. Currently, Darshan leads the development of India BIM Adoption Action Plan. This strategic plan aims to boost BIM adoption in India's construction and infrastructure industries, addressing gaps, estimating resource requirements, and launching capacity building programs. Over to you, Mr. Darshan.
Thank you. Small announcement. ACC India Annual General Body meeting will be held by 7 p.m. It is deferred by 30 minutes due to paucity of time and other reasons. So 7 o'clock AGM will be held at the same hall. All the ACC members, please be there. Thank you. Thanks, and thank you to everybody for waiting on. I know it's a bit later than planned, but hopefully I'll take you through this journey in terms of what we want to do in the next 14 minutes or so. So I'm just going to start out by talking about what we do at Arup very briefly, and then move on to explaining in terms of getting an understanding of what we mean by BIM and how it can be applied to tall buildings. I'll try and do that through some case studies. Also try and explain what we mean by BIM as a process rather than purely as a model. When we talk about BIM as a model, it's more about an information or a data model rather than a geometric model. We'll discuss some of the benefits of doing it, some of the uses of BIM, and also have a very quick look, if time allows, in terms of what Arup considers the future of tall buildings. So, in terms of Arup as a firm, we've been doing quite a few pioneering structures around the world over the last 75 years. And Arup as a company is an employee-owned company, so everybody who is at Arup is a shareholder, which allows us to think freely and independently and do specific things. Everybody at Arup likes to solve problems, so that's what we do. We're 75 years old, over 15,000 staff, 89 offices all around the world, turnover just over 3 billion. Have a presence in India for over 40 years. A number of structures that we have worked on, including, if you want to consider tall structure, the Statue of Unity, project for L&T, Arup involved with a number of engineering services, including structures, MEP, geotechnics, facade, which was particularly tricky, and vertical transport. In Hyderabad, we have been involved with the design and development of the airport. This was delivered 2011, as well as we do a lot of master planning for large cities and sustainable projects like redevelopment of Ulsar Lake in Bangalore. As an organization, we not only do design, but a lot of things applicable which are related to design, such as technical consulting, which is related to things like fire engineering, facade design, as I explained. But we also have a range of advisory services. So in a way, we go through the project life cycle in terms of expertise. So if you're looking at tall buildings, we go through concept definition, planning, financing, in terms of policy formation, looking at how we can actually go about preparing in terms of assessment, program and project management, the actual design, operational readiness in terms of handover, in use such as asset management, as well as repurposing and reusing what is there. So it's all about a holistic approach to total design, using local knowledge but a global expertise that the firm can offer, as well as trying to embed digital into every aspect of design, as well as establishing a sustainable practice and expertise. Arup itself is very keen to look at aligning its projects with what we call the UN SDGs. For those of you who are not aware, these are 17 interconnected goals which were established by the UN General Assembly in 2017 and are about betterment of the life of the common man across the globe. And that includes removing poverty, hunger, as well as looking into aspects such as to do with inequality, climate change, environmental degradation, and how we can go about stopping it. So from an Arup perspective, we like to work on projects where these are critical. An example of that is we are working at the moment with the Indian government to try and help it create policy in terms of digital and BIM in the construction sector. It's primarily driven by infrastructure because there's a huge amount of infrastructure investment happening all over India. And one of the enablers in terms of trying to be better, build better in terms of quality, in terms of saving money, it's about introducing things like digital in construction, which includes BIM. So that's what we do. In terms of Arup and tall buildings, well, I think as a firm, we have been involved with some of the most prestigious structures all over the world. You can see some of them on the right. I'm not going to name any. There are just too many to name, but over 350 buildings which are over 150 meters tall. And this is a unique expertise. So because of the expertise we have globally, we use that to fine-tune our projects. Things that we are very proud of in terms of how we design include design for performance. Think of making a structure as lightweight as possible, make it adaptable. With modern methods of construction, try and incorporate an appropriate level of design for manufacturing, which means how much of the structure can be assembled and built and lifted onto site, which has health and safety implications. We also do a lot of very difficult facades, as well as try and maintain low energy systems and try and make the building as adaptive and responsive as possible. An example of that is recently, well, it's nearing completion. This is 8 Bishopgate in London. It's a 50-story building and is classified or is trying to achieve BREEAM outstanding. BREEAM's similar to LEED, so it would be sort of on the LEED platinum level. And it has achieved that at the design stage and is on course to achieve that on completion. So this is 8 Bishopgate in London, which is 50 stories, 52,900 meters square of office space with lots of terraces. There's a 200 people auditorium at the top, along with different cafes and office space. Arab has been involved in terms of multidisciplinary design, working with architects to take their design to fruition. In terms of BIM and application of this, we went in as a structural engineer and the lead consultant on this, working with an architect to try and establish a combined, or what you call a federated BIM model. What that allowed us to do was check and review any changes that we were making in design and how they reflected on cost in terms of assembly, in terms of construction, and as well as in terms of primarily the space that needed to be used. We were able to do a number of different analysis on these things, and what that allowed us to do was we allowed ourselves to actually minimize the amount of material we are going to use in terms of the structures, which meant a reduction in carbon. So we used quite advanced analytical methods and tried to define and design every structural element in terms of its individual load and what it would bear as a load across the life cycle of the project, all the way from building, in use, to disassembly, which allowed us to save about 25% in terms of the overall steel, and which resulted in about 5,000 tons of CO2 savings, which was great. And taking this granular approach in tall buildings is only possible because we have a lot of experience in doing it. So rather than clustering different structural components, this was done at a very optimal level in terms of design. So it provided the solution that the architect wanted. So you can see a cantilevered structure going from the 15th floor upwards, trying to maximize the space in a very congested site location, but at the same time looked at costing on the fly in terms of being able to do that. So that was a big win-win. And that was only possible because of digital engineering and the coordination with the different disciplines involved. One of the speakers in the morning had said about the importance at concept to involve everybody. And that is actually key, because BIM, or Building Information Modeling, is all about not working in silos. It's about creating and making information available to everybody else as soon as possible, which saves a lot of rework, but you need to be able to do that in a very structured manner. And that's where BIM comes into its own. Another example of where you're doing digital engineering, a very different example, I would suggest this also is a tall building, but not your typical tall building. So I'm sure a lot of you have been to Barcelona and have seen the wonderful structures done by Antonio Gaudi. One of the structures which you will be familiar with is the Sagrada Familia, which is an unfinished structure. And Arab at the moment are still working, it's still not been completed, but we have tried to do better design and stick with the concept in terms of how it's been done. So as you can see, we are trying to increase the rate of construction by a factor of 10, but at the same time trying to reduce material consumption. And that is possible because we've been able to create detailed digital models of what we needed to do. We have been able to prefabricate a lot of the stone cutting off-site and using accurate CNC to do the stone cutting, because obviously we don't have the type of craftsmanship that used to exist previously, so we have to rely on CNC machines. Glazing is also done off-site. It's all fitted in, and we work to an accuracy of about plus or minus 1 millimeter on site. So all of it comes together like a jigsaw. You're working at night, you want to try and have better health and safety, and all of that that is happening while the site is open. It is an operating church. So there are lots of visitors, hundreds of thousands per week, and we have to maintain the quality speed of construction as it goes along. So obviously Arabs are one of the parts of the puzzle. It's a bigger project with the Sagrada Familia Trust and Arabs helping out on a number of things, including digital construction on that. So that's another example of creating a digital model in terms of what you would call a building information model and trying to do a unique structure, which is still not complete. What I would like to do is take you back about 10 years. So when BIM as a concept in the UK, so in the UK government has mandated the use of BIM on all government-funded projects. Largely infrastructure, but it also applies to buildings like hospitals and other infrastructure buildings that the government is spending money on. So we worked with Autodesk about 10 years ago on a research project. And the idea was, let's try something different and actually test out what we can and can't do with BIM. So what we did was, if you look at the human body and look at the ducts and pipeworks, do they resemble the ducts and pipeworks, as in, do the ducts and pipeworks resemble the veins and nerves in the human body? And we thought they did. So based on that very innocent observation, we built a Revit model of a 170-meter tall, 35-story building and tried to be as realistic as possible with some of the systems inside it using Revit. What we developed, I think, has changed how we apply BIM within the organization, as well as has been a great learning experience for UK industry. Because what we were trying to do was, it comes out of MEP again, but what we are trying to do was replicate the human systems. So respiratory in terms of mechanical ductwork, circulatory in terms of mechanical pipework, nervous system in terms of its electricals, and then obviously the structures, which is a skeletal system. What we found very quickly was that there were limitations, and the limitations were not to do with the software. Revit was very good. The limitations were due to the fact that we didn't have inbuilt control objects that we could use to start storing data and information. Because, as I said earlier, when you're looking at building information modeling, you're really looking at an information model. You're not looking at a geometric model. So when you have an information model, think of it as a database. And you want to have a structured database which you can use to store different sorts of information in. And that didn't exist, not because it didn't exist, but I'll give you a good example. When you want to create a good drawing, think of Revit as the canvas. And on that, you are the artist, but you have part of the canvas and you've got the artist, but you also need good tools. You need the right paint brushes, you need the right paint to actually do the actual drawing. And what didn't exist was those object models. So those had to be created to define the different MEP systems. But that led us down the path of actually doing that for MEP and other components, which we then have now rolled out across different parts of Arab as a standardized library. So that was a good learning experience, and in a way helped us understand what we meant by creating a BIM model, what we meant by trying to use Revit as a database, and then how that information could be shared with different components, so the architect, the different engineers, the different specialists, through what you might know is called a common data environment. How do we set it up? How do we create the flow of information and make it all seamless? So that was a great learning experience. And then in the future, we are thinking, it hasn't kicked off yet, and I don't know whether we'll do it, but there are aspirations to take it a bit further and start to understand a few things more. But it was a really good experience. So that takes us to where we are now. So we've been working with, so hopefully got an understanding of where we come from, what we mean by BIM, but now how do we apply that in the Indian context? And we've been working over the last 6 or 8 months with, as a part of the UK-India initiative with NITI Aayog to try and understand what does the BIM rollout plan for India look like? Where is the industry? So a few slides about that. Not going to touch on that, but this is a slightly older definition of BIM, and it still talks about multidimensional models. I think that is a bit misleading because we need to talk about different attributes and data types and think of BIM as a process rather than purely a model in terms of a 3D model. So we're trying to move away from the concept of, oh, we got a 3D model, a 4D model, a 5D model. Instead of that, think of, oh, we got a Revit model, which gives you the geometry, and we want to add different attributes into it rather than dimensions. And by those attributes, we mean attributes such as time, so your construction methodology, planning. You can think of it in dimensions, but I sometimes think dimensions are misleading. They're more to do with different types of data you want to incorporate into a data model. What we found was, I think, overall in India, there's a lot of capacity and capability, and there's a lot of opportunity to implement BIM, especially on large projects. And when I say large projects, I mean both infrastructure projects as well as large portfolio building projects. And that needs to be improved, but it can't happen overnight. That base needs to be built up. Because it's to do with not only capability and capacity, but also to do with the maturity of the market. What we found, and this is from infrastructure projects, not from building projects, but at the moment, with the amount of spend, there's a lot of opportunity to reduce the inefficiencies. Number of projects delay, there are cost overruns, as well as certain inefficiencies. Now, just to bear in mind, not all of these inefficiencies are to do with the fact that we're not using BIM. These inefficiencies are there because there are a number of factors. One of the key factors is to do with the fact that not only is there not enough capacity in the market, but we have a very fragmented supply chain. Productivity is lower than expected. Construction costs are much higher. And when I say that, they are higher than other countries with similar income levels. Slight inconsistency in project delivery, like contracts we have. Innovation could be better, and we could have better sustainable practices and increase our capacity and capability in terms of certain areas where we have skill shortage. So rather than looking at as deficiencies, I would say those are opportunities for us to try and grow, because I think there is a huge prize at the end of it. If we apply BIM within or digital construction within the Indian market, what has shown is that you get good quality, you can save on money, and it also saves you on time. It also has other intangible benefits such as improved asset management, improved health and safety, as well as reduction in abortive work and lots of other things. So one of the projects we're doing for a station in the UK, I think the estimated savings are close to about 12% based on an initial extra investment of 4% into technologies like BIM. So what we need to do is try and understand what the requirements are. I'm not going to go into that in detail, but essentially, the four main things that we have identified is most organizations, when they go into BIM or digital construction, need to have a comprehensive strategy, get an understanding of what data do they need, when did they need it, and why they need it. They need to do that across the different construction stages. They need to stick and use common standards which they can use across different projects and align themselves with existing standards such as the ISO 19650, which is quite high level but is a good model in terms of information exchange and has been adopted by a number of the G20 countries in terms of digital construction and information exchange on projects. Hasn't been adopted by India yet, but there are ways in which it can be done. Because yes, India is very specific, but there is a way in which you can develop annexures and specific standards which are related to it. So what do we do from an Arab perspective when we approach projects? First thing we do is assess the needs. Why do we need BIM and digital construction? And that's the first question we ask most of our clients when we sit down with them. Why? Why do you want to implement BIM? What are your requirements? Once we understand the requirements, clients themselves are not going to produce any of that information. It's going to be produced by the consultants. How do we get them to do that? Is it written within the tender? Is it written within the contract? How do you actually go about planning and appointing people, mobilizing, setting up the common data environment, and then going into production and asset maintenance stage? So it's a process that needs to mature over a period of time. And maybe that diagram explains it slightly better. It's too detailed, but essentially what we're trying to do is find out what the information requirements are, write those into contracts so that the consultants can deliver them. The delivery is done by supply chain. There needs to be automation in terms of checking how the information being received by the consultant from the consultants can actually be checked against the standard that we have asked them to produce it at. All of that happens within the digital environment of the common data environment, so setting that up, and it goes across the different project life phases. So that's what we usually do when we sit down with clients and go through that and get an understanding as to which parts of this need to be developed and how we can go about developing them and setting them up. And what we have tried to do is classify it into three things. So there's your production, there's your engineering side, which is your BIM task team, which is actually doing the production of the information that is happening. There's the BIM management and coordination, which is setting up the standards, doing the coordination, doing the quality control. And then the third bit, which is the BIM advisory, in terms of, from an organization perspective, setting up the overall strategy and developing the documentation that is required to go hand in hand with it. Typically, for a real estate workflow, we look at the different stages in terms of analysis, design, construction and use, and go from land acquisition to development strategies to being on site, being with consultants, designing your building, and of course this process is not, there are going to be overlaps, but that's the overall process. So we try and overlap that with the different models that would be built, such as 3D model, the project information model, the as-built model, and the asset model. We also try and define what level of detail or development is required. That might be too detailed for this conversation, but what we're trying to do is, if you are defining certain objects to be created with information within them, then based on the level of detail provided, you might be looking at, say, for an asset maintenance stage to an LOD 400, but you might not actually need it. You might need a lower level depending on the overall organization strategy, because more detail can be given by a consultant, but you may not need it. So why ask for it? Because you're wasting money. What you can use it for? Lots of stuff. Asset management and maintenance, space utilization, retrofitting, carrying legacy information, and single source of truth. So there are lots of not only capex as in capital expenditure benefits, but lots of operational expenditure benefits which need to be measured. But all of these need to be captured right at the beginning. So hopefully I've given you an idea in terms of what the overall methodology should be, what we mean by BIM, how it needs to be applied on projects. A couple of case studies right at the beginning to look at. So what I'm going to now do is take you through some simple use cases that we have looked at and take you through them in terms of how we apply BIM. First one, simple, I think, visualization of integrated MEP and structures within a BIM model. This is at a roof structure in Europe, and this is a model created by our office in the Netherlands. Another one, what is the value of BIM? So if you can see, that's a building with a quadrangle. It needs covering with a glazed roof. By actually modeling elements, structural elements in there, we were able to work with the manufacturer to understand what the optimal glazing requirements were. Very similar to the previous example in Sagrada Familia, but in a very different scope and scale here. Now, one of the things I'm sure is saying is, how does it apply to tall buildings? I think if you have that type of structure within a tall building, you wanted to do that, you're working at height on the podium, and you might want to apply some of these in terms of higher quality of information, which will allow you for better decision making. Another value of BIM is obviously integrating MEP and structural elements, as was the case in the first one. This is a more detailed model for an industrial building where it comes into its own, because in an industrial building, the structure itself sort of needs to fit around the MEP because that's much more expensive and important, and this will allow better coordination in terms of spatial as well as decision making in terms of monies. You can take that a bit further and look at building sequencing, which was one of the examples that was shown earlier, which was a good example in terms of overall traffic flow management on site and within the building itself. So in a way, and again was expressed by the speaker earlier, which was again a very good thing, you're trying to reduce risk with increased confidence in design, construction and operational costs. So you're sort of building the building virtually first, and then you are building it on site, which is very close to the accuracy you want, which is all about risk reduction and increasing value. You can take it a step further and then start looking at these not only for spatial coordination, but in terms of information that can be embedded within the elements, which can be used for element information at the facilities management stage. So this is not only helpful for contractors, but as well as facility managers. And that's where we go beyond the dimension of looking at things purely as a geometric model, but more as objects into which you can embed other information. Same for spatially coordinated design. Another example of that, you can play around with not only the geometry, but different flow rates. So it would allow you to do some analysis, not only in terms of visual, but in terms of capacity planning, amount of air supply and flow that you need to manage. So these are all different types of integrated models which you can use. And this again is about spatial coordination. You can do from an architectural perspective, shading studies, quantity takeoffs. If you have a database in terms of BOQs which are standardized across your project, then you can link them with different elements within the building to do quantity takeoffs. So exact update on bills, getting room data sheets, creation of models with integrated information construction elements within it, all of that is possible. You can also do cost estimating, and I said I don't like dimensions, but this is an example of 5D planning in which you're looking at how your capital expenditure is going to look like over the overall life cycle of the building. So you're not only combining your geometry, but you're combining it with the construction planning sequence, and then adding in quantities to it to show a build-up of capital expenditure that will go through. You can take it a step further and look at life cycle costs. You can look at it in terms of embodied carbon. So what I'm trying to get at is you can add different elements into it. Just remember, Revit's just the canvas you're going to use, and it's going to supplement and link into things like Primavera software to give you other sorts of things that you can use from it. But none of it is actually embedded in, so you need to build that into what you're trying to do. You can incorporate that if you have a larger site with a geographic information system, which gives you a better feel, not only in terms of what you're doing at the micro level, but more at the macro level in terms of site management. Visualization, very, very useful in terms of things like that. So an example, not from tall buildings, is in rail in the UK, if you want to put something across existing rail lines, you can't just stop the railway. You need to plan it maybe a year in advance. And if you've got a specific type of bridge you want to go over, just like you can build before, you want to try and sequence things and get them together before you would build them. So that would be really interesting to do. Very much possible with trying to integrate your 3D model that has been created within Revit by adding the planning dimension to it, as well as other things that can be incorporated. Sometimes you want your visualization and structures to be better for non-structure people. So creating analysis and simulations through what you want to do in structures, which is already available in different software design packages like ETABS and STAT, but essentially linking those into your 3D model so you can do it on the fly. Advanced 3D modeling, parametric design, which you guys, a lot of you from structures MEP background might be interested in, but looking at in terms of parametric design and associative design, and then linking the two in terms of not only changing the parameters of the certain elements that you're designing, but also looking at associated elements to it and how those would change. Using things like Grasshopper for design optimization, crowd flow simulation in terms of how things would work in terms of people flow modeling, which is quite important nowadays, especially for tall buildings for evacuation. Daylight analysis simulation in terms of heat absorption becomes critical in things like hospital buildings, and also analysis in terms of 3D in terms of light effects for a model. So I'm going to stop there now because time's up and it is a bit late. So there is a section to do with future of tall buildings, but there's also literature available online which you can look up, which talks about different aspects of tall buildings going ahead, which is A, they're going to be intelligent because it's all going to be data driven, lots of robotics in terms of self-repair, digital fabrication. They're going to be much more human-centered because we need to make them playful, participative, and healthy. It's going to be all about circular economy, so less waste. So it's going to be how can we reuse things going ahead, and there's some examples of that. Make it a bit more inclusive in terms of intergenerational use, gender sensitivity, and usable and safe 24/7. More integrated with transport and local networks, acting as cultural hubs. A bit more adaptive in terms of modular and temporary constructions, and regenerative in terms of being carbon positive and biodiverse. So this all applies to tall buildings. There is a detailed publication available online which goes through examples about this. And the last but not the least, resilient. So with that, I would like to conclude my talk. Thanks all for taking the time to listen.
Thank you so much, Mr. Darshan. And with this, we come to the end of the sessions for the first day. And I think it's really been a very productive learning day for all of us here. I request ACCI founder member Dr. Ram Prakash Ji and ACCI Hyderabad Center MC member Engineer D. Harikrishna Garu onto the stage, please, to felicitate Mr. Darshan. Are we all so tired? Thank you. I really feel जैसे किसी ने हनुमान जी को संजीवनी पर्वत लाने के समय, somebody had to tell him, okay, you have all the energy in you, you can do it. So to make the audience clap, all of us clap, I think I need to keep on reiterating. Please clap, please applaud ourselves, applaud yourself. Let's all applaud ourselves for being through the day and exchanging knowledge, networking with people, meeting new ones, and learning lots and lots of new things. So, can we give it up for all of us today? One big round of applause, please. Thank you, gentlemen and ladies. Thank you so much. I have one important task at the end of the day, which I think is very important to perform today. Most often than not, the people behind the Iron Curtain who work tirelessly go unnoticed. A small appreciation, a small acknowledgement, I think is a very small token of gratitude that we give to these noble people. And I take this moment to call our ACCI Head Office Bangalore staff, Sri S.D. Anegowda, who is the Manager Admin, Ms. Deeksha, who is the Admin, Mr. Ekambram, Admin Assistant, and Mr. Venkatesh, Office Assistant, on the dais, please. These are the men who've been constantly working, constantly coordinating with all the centers, replying to the phone calls, replying to the mails, coordinating with each and every small query. And I think they deserve a bigger round of applause. And to felicitate these people, I call upon the Hyderabad ACCI Center Office Bearers, Chairman Kashiram Garu, Treasurer Ramesh Garu, Secretary Bhimrao Garu, and our own VP South, Sri Rajkumar Garu. Your claps and the sound of your resounding claps are an appreciation to their presence. These are the ever-smiling staff. Whenever we meet them, they're so polite, ready to do anything for you. With this, we call it a day for the sessions today. We shall all meet up tomorrow 9:30 a.m. sharp for the sessions to begin. And as you all know, the devil's advocate, I would prefer to start the sessions on time so that I do not have to keep curtailing the time of the speakers and we can listen to the best of the presentations they've made for us. All the participants in the audience, except for the office bearers of different centers, we can leave the hall because we have an AGM to follow. Thank you so much. Have a great evening. Members of ACC, please stay back since you have an AGM. Other than that, the participants, we can call it a day. Thank you.